Hey, question 7. So paper's starting to ratchet up a little bit. We're starting to see a few more trickier questions coming in now, I think. A little bit of problem solving. Okay. So yeah, question 7. The triangle is shown below and calculate the size of smallest angle. Okay, smallest angle. Now again, that's an interesting question because how do we know which is usually you can tell, right? But how do you know for certain which of these is the smallest? It's to me, these two are looking quite big, that's looking quite small, but can we categorically say that that is the smallest angle? Okay, again, technical issues. Well, the smallest angle is always going to be opposite the shortest side. Okay, now it just makes sense if you think about it. Okay, if we have, let me just go here, say this is a triangle here, not a very good triangle, but say it's a triangle. This is the smallest angle, and we would agree this is the smallest side. Okay, as the angle gets bigger, the side opposite it gets bigger and bigger. Okay, so if we're looking at these triangles, the biggest angle is going to be opposite the biggest side, so that's going to be that one, and the shortest is going to be opposite the shortest side. Okay, so that's how you can usually just look, and also, again, common sense. If you don't really know, just do the calculation once or twice, and then you'll know which is the shortest one. Okay, but I'm quite happy that this angle in here is the shortest. Okay, and the next thing is, well, how do we do that? Okay, we've not really been told. There's not an awful lot of equations we've been told in Nat 5. Okay, and really, when you see a question like this, you should be thinking sine rule or cosine rule. Okay, the key to this one is we've only got sides. Okay, we've got no angles. We're trying to find this angle in here. Okay, we're trying to find z, but we've only got sides. So right away we can't really do the sine rule. Okay, sine rule will be where we've got a mixture of angles and sides. But the cosine rule, if there's three lengths or there's two lengths in an angle, trying to find another length. The minute there's three lengths involved, that's when we're thinking, okay, it's got to be the cosine rule. Okay, so in this case, the cosine rule is going to be cos of, we'll call it z, okay, which is the correct number. And let's just label these up. So we've got, if I chose, I'll write it the original way, and then we'll just substitute in. We'll do that. So it's cos of a is equal to b squared plus c squared minus a squared divided by 2bc. Okay, and it doesn't matter what b and c are, but it matters what a is. Okay, so this has to correspond to this. Okay, so this angle has to correspond to this length, i.e. the a here has to be the a here. Okay, the b and c's we can actually mix up. It doesn't matter if it's b or c. Okay, but this has to be our a. Okay, so that's actually the same as saying cos of z is equal to, we'll call this one, we'll just call it b, call it c, and we'll just remember that's a. Okay. So 7.2 squared plus 8.5 squared minus 6.3 squared divided by 2 times 7.2, again being consistent, b and c, times 8.5. Okay, and that's very important that we get this angle and this length corresponding. Okay, and we actually look at, there's not a huge amount of room for error apart from that. Okay, because you can put b and c around the wrong way, or not wrong way, they can be either. Okay, but this has to be as it is. Okay, so if we work this through in a calculator, we're going to end up with cos of z is equal to 84.4 divided by 122.4. And again, watch your calculator. Okay, make sure it's squaring the individual numbers, it's not squaring everything, etc. Okay, so cos z is equal to that. At this point, we need to do the inverse of cos. So we do shift cos of this number to get cos onto this side of the equation. We want z on its own. Yeah, So to get z on its own, to undo cos, we do z is equal to inverse of cos, which is cos to the minus 1, 84.4 divided by 122.4. Okay. And that should come out as 46.41 degrees. Okay, so just to sum up that question, if you weren't sure about the angles, which is the smallest angle, you could have just done this a few times. Okay, and then in terms of equations, the minute you see a question like this, have a look at your formula sheet. Okay, it's going to be the sine or cos rule. There's not really a lot else we've learned. And for me, the big one, if it's got 3 lengths in it, that's going to be a cos question, cosine question. Okay, and then remembering that the angle, the A, has to correspond with the length opposite it. Okay, so this couldn't be B or C. This has to be the length opposite. Okay, the B and C could be either 7.2 or 8.5, doesn't matter. But this is important. Okay. And again, common sense check. Does the number look sensible? I'd suggest it does. 46 there looks quite good. We were getting something beyond, 45, like really big. If we're getting, 70 degrees, 100 degrees, I think we made a mistake somewhere. But that does look like 45 degrees. Okay. So yeah, good stuff on that one. Okay. Shape questions. And again, the volume questions. Go to your worksheet at the front. Go to your calculation sheet. So your formula sheet. You've got everything in there. Okay, you're not really asked to remember a huge amount. Okay, so we've got our formula sheet in front of us, and we've got our shape. The next thing you really want to do is draw a sensible diagram. Okay, so I'm going to draw an elevation of this. Okay, and I'm going to label up with some dimensions. So we know the full height of this is 70. Okay, so I'll put 70 over here. That's the full height. We don't know what the height of this is just now. We know the base is 24, so that's good. But if we actually want to split this into two shapes, the sphere, the hemisphere, and the cylinder, we're going to need to know the height of each of them individually. Okay. Now, if we know that that's 24 and it's a sphere, then the height of it is going to have to be 12. Okay. So if you imagine your sphere, that is your diameter, 24. Then this is also the diameter, 24. So if we just get a hemisphere, that is going to be half of the 24. Okay. So we know that's going to be 12. Okay. For the height of this bit. So that'll be the height of this, not 70, oops, getting late, 58. 58 plus 12 gives us 70. Okay. So now we now know the two heights of our two shapes. So that's quite good. And we've got a formula sheet in front of us, so we'll try and break it down. Okay. We call this shape 1, and we'll call this shape 2. Okay. So for shape 1, we've got a hemisphere. So we know the area of a sphere is 4/3 pi r cubed. But we get a hemisphere. Okay. So we want to divide that by 2. And that's the first mistake folk will forget, it was to put that in. Okay. So if we substitute that in, we're going to have 4/3 pi r cubed. So our radius is going to be half the diameter, so it's going to be 12. It's going to be 12 cubed divided by 2. Okay, so if I do 4/3 times pi times 12 cubed divided by 2, that's going to give me, over here, that's going to give me 3619 units for that. But in centimeters, we're doing volume, centimeters cubed. Okay, so that's our first volume. Again, classic mistake here, doing r squared rather than r cubed, which is silly because we're being given the formula. Okay, I'm going to put 2 over here. Okay, now actually the volume of a cylinder isn't given. Okay, but it kind of is because you get the volume of a cone. Okay, so the volume of a cone is 1/3 pi r squared times h. Okay, now a cone is 1/3 of the volume of a cylinder. Okay, so if you forget what the volume of a cylinder is, look to the cone and just take out the third. Okay, it's exactly the same. So what I'm kind of saying is if we had a cone and a can of Coke that were similar in height and the same circle kind of radius, if we poured the Coke can into the cone, it would be a third of the volume, So there's a few videos on YouTube if you want to go and look to just see that works, okay? But so actuate is given as well, even though it's not explicitly stated, okay? So look to the cone and get rid of the third, okay? You can, obviously, if you can remember, that's brilliant, but if you can't, it is there, okay? So we know pi, that's fine. The radius for this one, again, is going to be 12. That's going to be 12 squared, not cubed this time. And the height is 58, not 70. Okay, that's again another thing. People rush in, they see this, they do 70, and they make a mistake. Okay. So put that into the calculator. That is going to give me 26238.6 centimeters. Okay. So that's volume 1, that's volume 2, and obviously we have to add them together. Okay, add them together, that's going to give me, add them together, that's going to give me 29857.6 centimeters cubed. Okay, again, I've just kind of written this randomly, okay, in space here. It makes sense to obviously, your book maybe a bit smaller than mine. I'm still kind of getting used to this pen, etc. So yeah, you just maybe write out explicitly what you're doing, okay? Because again, some people would do a full sphere here and then say, well, half of one plus all of two, you know. So just make sure it's clear what you're doing here. And also, this is again another way of just dropping silly marks. As a 5-mark question, the last little bit is the 3 significant figures. Okay, so again, do it as is, and then for the last bit, put the 3 significant figures. Okay, so for this three significant figures, our 3 significant figures are 2, 9, and 8. But we need to round up the 8. Yes, we need to round up the 8 because 5 means we're going to be rounding up. Oops. Go. The expression with some of the younger students, I always say, find your place, look next door, 5 or greater, add one more. But yeah, I think by this point we should kind of be over that. 299, but then obviously we need 2 zeros, okay, just to make it, to get a place value, okay. So that's easy not to read that for a start, okay, so just double check if you've read the question. And then significant figures are tricky. Sometimes people will just write 299. Don't forget you need your place value. Don't put point. If you put any zeros, 0.00, they count any significant figures, okay. So practice if you're not sure, but if it's talking about 3 significant figures, you should see 3 numbers more or less, and then you'll have some zeros afterwards to get a place value. Okay, and that's your final answer.